everyone, I'm Alexis Saraklis, and today we'll be talking about prokaryotic genetic regulation. Before we get started, please pause the video to look over some terms you'll need to know for our topic. Let's begin by first looking at the various types of transcriptional regulation in prokaryotes. There is negative inducible, positive inducible, negative repressible, and positive repressible, although for our discussion we'll be focused on the positive inducible systems. So how does a positive inducible system work? Well, positive control refers to the regulatory protein being the activator, which means that when the protein binds to DNA, transcription is turned on to make the gene product or products. Inducible control refers to transcription being turned on after the small molecule, known as the effector, combines with the activator to activate it, and the product of the two bind to DNA. Here is the segment of DNA and its parts that are regulated by prokaryotes through transcription. First, we have the regulatory gene, or in the case of the positive inducible system, the activator gene, that is transcribed and then translated into the activator protein. The operon is a section of the DNA where transcription occurs, with the promoter region being where DNA polymerase binds, the operator being where the activator binds, and the structural genes that are transcribed and translated into our gene protein products. To have these structural genes coded into our gene products, RNA polymerase must be able to bind to the promoter, travel down the DNA strand, and move through the operator region to get to the structural genes. In the case of our positive inducible mechanism, RNA polymerase is unable to bind to the promoter region because the operator blocks it until an activator comes and binds to that location on the DNA strand. Until then, transcription is off. To remedy this, the activator gene makes an inactive activator that then recruits a small effector molecule to pair up with. And when the two are combined, the activator then becomes active, and this is known as inducible control. Now that there is an active activator protein, it is called to bind to the operator region, where it stimulates the operator to recruit RNA polymerase to the promoter region so that transcription can begin. With the operator being activated and RNA polymerase being bound to the DNA strand, RNA polymerase can then move downstream of the operon to the structural gene region. This is where transcription is turned on in the process of transcribing mRNA and then translating the mRNA into multiple gene protein products occurs. These gene products play an important part in the structural role of the cell or are used in metabolism. To gain a better understanding of the positive inducible regulatory mechanism, let's look at an analogy using the hit TV show The Vampire Diaries. Our focal points are Damon and Stefan, who are vampire brothers, and Elena, who they are in a love triangle with. This trio are also involved in keeping the town safe from supernatural entities. To show how this relates to our positive inducible system, we'll be using the analogy of saving lives as our transcription/gene products, with the binding site being Mystic Falls, home of our dynamic trio and hotspot for supernatural drama, the activator protein being Stefan, RNA polymerase being Damon, and the small molecule being Elena. Damon is a vampire who lacks self-control and has a tendency of going off the rails, but when Stefan and Elena work together, they can use Damon's love for them to influence him into all three working together to save the lives of the people in Mystic Falls, hence creating our positive inducible system. That concludes this video. Thank you for watching.